So like I promised you, now we're going to talk about working with queues, with multiprocessing or multi-threading. And in case you do not, well, let's just create a file here, and I can call this maybe part 2 something.py. And so like I was saying, I would want to talk about 2 things. One would be threading, and one would be so more or less we can call this as a thread. So this would be a thread, and the next will be a process as it pertains to computers, more or less. So you could think of a process. A process could be let's say your Python interpreter. So these are like independently running on your PC, for example, and they do not share memory. So if you have 2 processes running, so one could be this application with which you're watching this tube right now, this video right now. It could be a process. The main difference is that if you have 2 processes running on your computer or whatever it is, they don't share memory. And with threads, of course, just know that a process can actually spawn multiple threads, and threads, of course, they share memory. So you could also think of this, let's say in scenario whereby, let's say you have your Chrome browser, for example. This could be a process, and for this Chrome to run in, you might have noticed that it also there, if you look, for example, through your task manager, you see a couple of other things happening. And what it means is that this process, in this case, for example, say your Chrome browser, could actually spawn other threads to do certain jobs in the background. And with all these threads that are spawned by this particular task can share memory. That's more or less the difference between both. I hope I have clarified that for you. But of course, if not, please feel free to leave questions with me, so I will always love to come back and answer those questions for you. So the first thing we would do would be to work with multiprocessing, to work with threads. So I would probably show you. We can actually start with threads and then maybe move over to processes. And so what I can do already is from the standard library, I can import thread from threading. And again, to work with queue, as you might have seen, import our queue from queue, import queue, and now we have our queue. So we've been more or less talking about this theoretically, but let's say we have a worker that's in the scenario example we gave, whereby we would want to process tons of pictures, for example, asynchronously. So I could define the function here, and I call it worker. And so this worker more or less accepts a queue as a parameter, and it runs infinitely. What is coming on? So while true, so I would like to run this infinitely. So what this would do more or less for me is to constantly pull items from the queue and then process it. So I would get an item from this queue, and just maybe I can type, close this up and add type and hints, so I can get nice highlighting. So what this will run, of course, as you can see, forever. So it will constantly listen to the queue and constantly fetch items on the queue. And what I can do is I can add a message here, for example, that says working on the task, and here I can provide item. So in this case, I'm probably going to just put a bunch of strings into the queue, doesn't matter. And what I can do here is I can call task done. So as you can see here, it indicates that the formerly enqueued task is done. And that's one thing we could do. And I think for now this is okay. Maybe what I might also, I think this is okay for now. Let's not make it too complex. And what else can we do? So now we can define our queue. So we define our queue, and let me put a couple of, so I can loop. Maybe I would want to put 10 items in here. Say for I in range 10, I'll put items in this queue, and I can put let me format this string again, so I can say task I, and then I think this is already enough to put items into the queue, and then I can create a thread, and with the thread that we imported. So a couple of things I need to provide would be the target. So in this case, the target would be this worker that I defined, and you always have to provide args, and this args always has to be a tuple. So I can't just do this like this. For example, I have to do it like this, so that it always is a tuple. And then I can do some like thread start, and like I showed you, if we wanted to block this queue until we've processed everything we put into it, you can do a join. And now let's run our code. So part 2. And now, as you can see, we've worked on everything we put in the queue. So we looked from 1 to 9 to put things in here, and as you can see, of course, this is listening infinitely, so that's why our terminal is not terminated. I can of course terminate this from the terminal if I wanted to, but what you would need to know is, of course, that this worker over here is actually currently running on a separate thread that we've just spawned here. And so that's really one way you could work with queues on threads. I would show you actually more detailed application afterwards, but let's move on to multiprocessing. So for multiprocessing, I would maybe also remove all of this, but I need to work with this too, so I can maybe import it this way. For multiprocessing, I import a process, I import a queue here. There is really no difference with the one we imported from here and the one we've been working with all day. So just to clarify. And again, I would want to create a worker that takes a queue as an input parameter, and what I would want to do is more or less, I'll keep this simple. So I just get an item. I can also use my string formatting and say item, and then I get an item from the queue like this. And maybe what would I want to do? Let's say I process this. Let's say there are gonna be a couple of processes that will be consuming this, and then when this is done, I want to put it back into the queue, for example. And then I can also do something like queue.put, and here I put whatever result I got. So I'll just put it like this, something like this. And now what I can do here, of course, I can do something like if name is equal to man. I hope you are not confused by seeing this line on line 14. If you are, I would need to do a more advanced Python tutorial to clarify things. And now I put something, and here I might put something like let's say here this is where you put the input, for example. And now we create a process. And now we create a process. Again, it's pretty similar to threads. So my target would be this worker function that we created, and again args also needs to be a tuple. So it stays like this. And we have created our process, and now again, pretty similar to threads, we start and we join. Again, what we can do, of course, we know that in the end this worker is going to put something into the thread, so maybe we can also do something like this. I'll say result, and here we say queue that gets something like this. Pretty straightforward. And we run our code again, and what happened? Don't save. So Python part, oh, sorry. So you see here we put in input, and here we read the item. That's why over here it says item, and then when this worker was done processing, we put the result back into the queue, and in the end we printed again, we got this again. But remember, this blocks the queue, that's so that everything it would allow this to process everything in the queue before it comes. So this is really a blocking process. But as you can see here, this is why we are able to get this again out of the queue. And that's really it, guys. So I would now want to show you more or less a more detailed example of how to work with this, and I'll show you a more detailed example with a couple of examples, so you can also maybe understand how a real process, a real application could look like. So let's really jump into that. So now I would want to show you more or less like a holistic, complete application as to what you could actually do with this. And maybe I'll just close my terminal for now, and then I would remove everything in part 2 more or less, or maybe I'll leave it and create a new file, and I can call this part 3. And don't worry, I would add a link in the end to the description where you can actually go to my blog post and then find the complete code over there. And so here I would like to define a class, and I can call this maybe I call this a job processor. If I can type processor this way, and I define a dunder method, the init method. And so here I would want to define a couple of things. So what I would want to do here is more or less to create like a complete class that could be used to process jobs. And in this regard, what we would be doing is that we would have a queue to which we constantly write data into, and then we have another process that's more, in this case I would use threads. If you remember in the example I just showed you, I showed you how you could work with threads and processes with queues, but for this example I'm going to use a queue. So we'd have a queue that would listen to messages from this thread, read from them, and process them more or less. So to that effect, I would want to define a couple of things here. So here I would like to have a shared queue in my processor, and of course this would, I can instantiate this already this way, and I need to import from queue, import queue like this. I don't need this pass anymore. And what else I would like to do is I would like to, of course, not, this should of course still be non-blocking, but I would like to lock, because I would want of course data to be shared, and I would like to use a mutex to log this data. So here I would define a lock, and I'll use thread and lock. And maybe before that I can already just import this import here. So I say import threading, and here I can say threading.lock, and maybe I also define the structure of my shared data. I'm going to shared data. So my shared data would actually be an object like this. Maybe I would want to type it actually to make it a lot clearer. So from typing, import dict. So I'll need a dict, I'll need a list. So here what I would want this to be, this would be a dictionary of like key value pairs more or less, and the value here would be a list of strings. So that's, this will be a dictionary of one, this and that, something like that. And then I can already show you what this could look like. So I can have something like, say the first value here might be topic 1, something like this, and it will be an empty string like this. And I can maybe I would want to work with 5 topics, I don't know. So this will be topic 2, topic 3, topic 4, and topic 5, something like this, pretty straightforward. So I would again want to define a couple of methods. So one would be, like we said, we would need one that would write messages into the queue, and I can call it main. So what this guy would do for me would just to constantly write messages into this queue without waiting for nobody. So I would say wow true. I just create some ID. I can call random, so I can import random this way. So I can say random.rand int, and I would want to generate a random number from say 1 to 5 because I'm working with 5 topics. Something like this. And here I would like to define the data that I would want to put into the queue. So here I can say topic. Again, it needs to match these ones we defined over here. So I can use my string formatting and say topic ID, so that it's always 1 to 5, something like so. It's always matching these ones. Just playing around here. And I can say payload. So this is the actual payload I'm sending over. And here I can say maybe something like timestamp. And what I would want to do is maybe I define a function down here. I can call this get timestamp. So this would be a function that helps me return a timestamp. I think, yeah, from Python it should be like this. Exactly. And so what do I need? I need date time. I don't know why this cannot help me in Python. This is really so sad. I can say from date time import, we need to import date time and maybe time zone. I don't know yet, maybe time delta. And so to get my timestamp, what I might want to do is I might say date time now, and I can use my time zone and get UTC time. And this I might say UTC time. This is my UTC time, and maybe what I want to do is format the time. I can say formatted time, and this would be UTC time. Let's string format time, and now I would want to do something like this. So I would want you to give me a year in this format. So I have month, I have day, and I have hour, I have minutes, I have seconds, like this, and I would expect a float at the end, like this. And then what I can now do is, because I'm expecting a string, so I can add my formatted time like this, and I want to trim out the last 3 parts. So there are a couple of ways I could do this. I can do this like this, or let me just do this like this. It's okay. I can do it like this. I think I can also do it like this. So I provide everything maybe until, I don't know, -2, something like this. It should also be fine. But yeah, so I make this part of the class, and my timestamp would be get timestamp, something like this. And I have my timestamp, and what else do I need to maybe make it interesting? I can say ID, and I pass the ID, the one over there, and then I pass some random value. And in here I can also maybe use a random int, maybe a rand int, and just give me a number between 1 and 100. I don't care, it doesn't matter so much. And now I've created my data. What I would want to do is put it in the queue, so we called it shared queue. So shared queue.put, and maybe what I would want to do is to dump this as a JSON more or less. So I would need to again import. As you can see, this is getting interesting. So we can have this sent as string. And now, so I dump the data, and then I don't want this to constantly dumping. So maybe what I would want to do is I need to import time, because I would want to sleep. So what I would do here is time.sleep. So, and I would want to sleep for 100 milliseconds. So this function, we constantly put messages into our queue. And so the next thing I would want to do is maybe I define, or maybe I call this, instead of calling it main, I can call this producer. I think that's more intuitive. So now I can define a consumer. So this function again is going to constantly consume messages from our queue. And one way we can do that, I can do why not, as long as our queue is not empty. Remember the methods we talked about. So empty. So as long as this is not empty, I want to constantly retrieve data from our queue. Shared queue .get. So remember this gets and pops, and so I can call this data string, and I can call this data JSON. So this would load our data to convert it to a JSON, more or less a dictionary. And now I would want to put this in this shared data. This one, I think this should be shared, not share. Do I have it anywhere else? I don't think so. So what I would want to do is to lock, to acquire a lock. Come on, before I modify this so I don't have any race conditions. So I can save that shared data, and I need to find the one that has the topic. I think it's here it's data JSON, the one that has the topic that matches what I'm getting from the payload, and then I would append the payload that I'm getting from that's so I think we called it payload. So if you look over here, we have a topic, and the topic would be either of these. So we want to find the one that matches this topic, and then we'll append this payload to it. That's more or less what we want to do. Pretty straightforward. So if you're using this, you can already think of ways you could already build complex applications around this. So let's put some print statements here. I can say we are processing our messages, something like this. I don't know. Maybe create a new line so we can always see what we're doing. And maybe here I can create a function that writes our message into a database. For example, so if we have a function here, say that is some like write to db, I don't know, and it's text a reference to self, and maybe just print something, I don't know, whatever. And then maybe here what we can do is rewrite to db, you know, I don't know, whatever we want to do. And so maybe in here what we can do, just so we can see something going on, is we can maybe create a job. I can call it jobs, and I'll use this list comprehension to fetch every item in our shared data. We fetch for all the topics where this list is not empty, something like that. So we can see shared data by key, dissect, we get the key, and this will be for key in self.shared data dot keys. I will say if length of self dot shared data of that key is actually greater than 0. I hope this is clear for you. So what we are doing here, I hope you are also familiar with list comprehensions in Python. It's pretty straightforward. So we want to create a new list out of this expression, and what this expression is we would retrieve all the items from this shared data, where we look all through the keys. These keys in this case will be these topics. We go through each items and we say we would want the ones where the content is greater than 0. So basically any of them that contain something, we would want to get those things. And what else can we do? And so we have this, for example, and what we can do is maybe just to, because we'll probably modify this, I can acquire a lock here. I can acquire a lock here and release it here, and so that I can do whatever it is I want to do in here. And what I can now do is, so let's just assume that anything that is greater than 0, I will process them, right? And then what I would now want to do is to clear those things out that I've processed. I can say for key, and again something pretty similar to what we have over there, shared data dot keys. So I want to go through everything, all the keys, and if any one of them, so if any one of them has a length greater than 0, if any one of them has a length greater than 0, we wipe it. Basically we wipe that one, because now we are assuming that we've processed it, so we'll make its lists completely new, right? And now, so what we can now do, so of course at this point we can release our lock and then we can continue our processing. So this is where you could write to the database, for example, blah blah blah, but here I would just print this out so you see. So I will look through these jobs and just print some statements. Let's maybe say something like I don't know, maybe write into the database, something like this, something like this, and here I can pass the job. So at this point it really doesn't matter what we are doing anymore, so that's why I'm releasing the lock here, because we have this already, and this, it's a local variable, it's not a global variable, so we can do with it with whatever the hell we want to do with it, doesn't matter. But the thing I would want to do is here, so I don't want this to constantly do this. I would want it to maybe sleep for a while before it continues, so I can add a message here and I say done processing messages. You can say sleeping, something like this, and now here I would just sleep. Maybe I'll sleep for 5 seconds and then I resume operations, something like that. It's pretty straightforward. So we have our consumer, which consumes messages and maybe probably writes them to a DB. Now what I would want to do is I would want to define a function that allows me to run one of these methods in a thread. So I can call this run in thread. So pass a reference to self. And what I would want to do is I create a loop, and I would need to import this from asyncio. So here I would want asyncio. I can call the new event loop, and so I'm going to pass a coroutine to this function, and so I create a new event loop this way, and then I can set the event loop this way. I can set which one I'll need, set event loop and I pass the loop. And what I would now do is I'm going to more or less let this run an asynchronous function. So I'm going to define a future. So async IO, and we can say ensure future, and now we pass our coroutine, and now we can run our loop, run until complete. That's what I want, and then we pass our future. Pretty straightforward like this. So we create a loop this way. We set the event loop, and then because again, like I said, I would want to use this, I would want to run an async function in a thread. So that's why I'm creating a future here, and then I'm running until complete. Pretty straightforward. And I think for now we actually have almost everything we need. So now I would need to instantiate my function, more or less our process, our class, and so we can test it out. So again, we do add our redundant. We use this again to check the name of a file. So this would be if name equal to main. What I want to do is I can call this job processor, so I don't know, something like this. So we instantiate our class this way. And then what I would want to do is so I can say maybe consumer thread. I'll create a consumer thread this way. Say threading dot thread, and now I'll pass my target. My target would be this job PRC dot consumer, like this, and ax would be an empty tuple because I'm not actually expecting to pass anything. And what else I would want to do, so I could create another thread where I can run an async function, because if you check here, most of what we've written here actually synchronous functions. So here I can just show you one in case you have one. So I can define a new function this way in Python. That's how we define an async function, async def, and I can call this I don't know, async function, like this. And what should it do? I think nothing. It's just gonna sleep for 100 milliseconds every time, and I will print a message and say laughing from the async function, whatever, something like this. And now what I would want to do is maybe to create an async thread to handle that. I can say async thread, threading.thread, and I can pass a target. So I would need, again, I can't directly run a synchronous function inside this thread this way. So that's why I would need to use the function we created. I think I called it run in thread, yes. And now as ax, now I can provide this guy, and then I can provide my async function, and again it has to be a tuple like this. And then I have to start all these threads before I start the script that will run on the main thread. So I can say consumer thread.start, just like that. And then I can say async thread.start, just like that. And now I can start our main thread. I can say async IO, let's get event loop. We can now say .run until complete. And now I can just pass this guy. I think, what did we call it? So it was our producer. So our producer will run in the main thread. Something like this. So if everything works well, we can of course test that out right away. And now when we run our function, so Python part 3, we see of course our async function. We send us this message laughing from the async function. And now we see our producer over here is constantly writing messages into the queue, and then our consumer also of course constantly consuming these messages that are coming in from the queue. So this would continue forever, but you get the point. So this is of course one way you could utilize queues to actually build powerful applications. And I hope like this was really insightful for you. Again, if anything was not clear, if there are open questions, or if there are things you would need clarified from me, please do not hesitate to shoot me a question, and I would gladly attend to those questions as soon as possible. And like always, thank you so much for being part of this journey. If you're new to my channel, please subscribe, and because I promise to always bring you informative and actually helpful tips that you could actually use in your software development journey, and of course I try to make it as easy as possible. And so until next time, have a lovely evening, and bye bye.